So, what have I been up to lately? Well, I've been spending a lot of time online doing osmium related things that, for certain reasons, I can't talk about. But if you Google some of the compounds I've made, I'm sure you'll figure it out. Recently, though, poor man's chemist asked me when I'm going to make an osmium oxalate complex. Not anytime soon. But out of cat killing curiosity, I decided to do a couple of experiments. Now, there are two compounds that come to mind: potassium osmol oxalate and osmol tetraamine oxalate. However, because I use bleach as what is essentially a cheat code, a shortcut for dissolving osmium metal, the sodium osmate solutions that I get as a result make osmol derivatives by and large inaccessible to me. One, because the solutions still contain bleach, and two, because sodium osmate is so soluble you can't hardly separate it from solution. Now, there's only two osmol derivatives I've actually made. Sodium osmol chloride, which I've made a few times and it's generally short-lived, and once, very briefly, osmol tetraamine chloride. And I wanted to try and find a better way to make osmol tetraamine chloride using what I have available to me. In a previous video, I dissolved osmium metal in a solution of bleach without any sodium hydroxide added to it. This produced a solution containing sodium osmate, sodium perosmate, and perhaps some osmium tetroxide. Upon adding ammonium chloride to it, a yellow precipitate of osmol tetraamine chloride began to form on the bottom of the vial. However, soon after, it reacted with chloramines to either oxidize or form some other compound. Now, when I dissolve osmium metal in bleach, it's common practice for me to add sodium hydroxide to it. What this does is it ensures that all the osmium is captured in the form of sodium osmate instead of producing osmium tetroxide. Now, as you may already know, unlike ruthenium, osmium does not react with bleach at room temperature. Heating is required. The application of heat also prevents sodium perosmate from being formed, as perosmates are reduced by heating. However, the resulting sodium osmate solution is completely unsuitable for making osmol tetraamine chloride. Addition of ammonium chloride to the solution releases ammonia. The ammonia, in turn, reduces sodium osmate, precipitating osmium oxydiamine hydroxide. So I decided to prepare another solution of sodium osmate, but without adding any sodium hydroxide to the bleach. I then added alcohol to the solution to prevent oxidation. This time, upon adding ammonium chloride, no precipitate formed, so I quenched the reaction off camera with sodium hydroxide. After quenching, the red color of sodium osmate returned, and the presence of alcohol turned it purple. At this point, my new objective was to recover osmium dioxide. Addition of hydrochloric acid dropwise kept forming what I'm assuming was the osmol chloride, which then, due to insufficient acidity, converted back to the osmate. I repeated this step, attempting to slowly reach a neutral pH, so that I could get osmium dioxide. The final dropwise addition of hydrochloric acid looked promising at first. However, the formation of a colorless solution at the top layer was foreshadowing of what would happen next. At first, I felt like I'd accomplished my mission, but as I was wrapping up filming, I noticed that it began to redissolve. And even worse, it was redissolving before it could even sediment. Addition of two final drops of hydrochloric acid caused the solution to go colorless and what little osmium dioxide rapidly redissolved.
Bunch of bullshit.
Asshole! You're an asshole! You are a fucking asshole! Now, I've seen this happen before, and in the past, it's felt like a dead end. But what's going on, and what even is it? Well, it's possible that a certain solvent was created that osmium dioxide happens to dissolve in. However, adding sodium hydroxide to these clear colorless solutions causes it to be converted back to the osmate. So this tells me that these colorless solutions are in fact hexavalent and may in fact be an organo-osmo complex. Now, in the past, once or twice, I have made a premature assumption of having acquired an organo-osmium compound, but this time I think it might actually be organo-osmium, because aside from these two compounds here, all of the colorless osmium compounds I know of are organic. And actually, it's not completely colorless. When compared to regular water, it does appear to have a slightly greenish yellowish cast. However, I've scoured the internet. I mean, books, scientific articles, journals, everything I could possibly find, and none of them come anywhere close to describing what's happening specifically here. And you know what? Maybe it's not an organic osmolar complex, but something tells me that this happens if there's too much alcohol in solution. Now, I do have an out in this situation because I recently bought some sodium formate, which is capable of reducing osmium-containing solutions to the metal. However, it reduces it specifically to osmium black. And just like iridium black, osmium black is in a much more reactive form. I've been told it contains large amounts of occluded hydrogen gas, and if it dries out, it runs the risk of incandescing and producing lots of osmium tetroxide. So it's not the most ideal recovery method. And I'm hoping to use that as a last resort only, because I want to get to the bottom of what this compound is. However, after storing it in desiccator beads for a couple days and then heating it with stirring, I'm still no closer to figuring out what it is.
Asshole.
The last time I had to deal with this compound, whatever it is, I got so frustrated with it I tried boiling the dioxide out of it. And while some osmium dioxide did precipitate out, it rapidly redissolved. Here, even that little bit wasn't even happening. The bits of dioxide you see floating around were already there. However, during the 2-day period it was exposed to the desiccant, mild staining of the plastic cap did occur, as seen on the right. The corn oil test, however, reveals there aren't any tetroxide vapors present. A small sample was then taken from the solution for testing. A single potassium iodide crystal was dropped into solution. Once dissolved, the solution turned yellow without precipitation of iodine. Hoping that the osmium had been reduced to a hexaiodoosmate of some kind, I inserted a couple prils of sodium hydroxide to see what would happen. This time, it became truly colorless.
Asshole. You're an asshole.
Right, so here's my assessment of the situation. I don't know what it is. I don't know if it's organic or not. I thought about investing in a vacuum desiccator at one point, but after seeing what happened, after 2 days exposed to silica desiccator beads, and it staining the cap and staining the other parts of the bottle, I think that it will stain everything before it surrenders and allows itself to be isolated. Now, I know some of you who watch my channel have refined precious metals before, and even fewer of you have experience with osmium. And I think you know what's going on here. I think you've seen this before. And I would be very grateful if you told me what is happening, what it is. If you do know, and you don't tell me, well, then you're an asshole. You're a fucking asshole. One person named Skivity G commented that I should try bubbling sulfur dioxide into it. When I get an apparatus to do so, I will definitely try that because this is a pain in the ass. I think thiosulfate mixed with acid might be a good substitute for that, but then you got osmium dioxide or osmium sulfide mixed with elemental sulfur, and you gotta, I don't know. Anyway, moving on. Remember that video I made a while back when I tried to make calcium osmate and I thought that I had failed? Well, I looked back at that and it turns out those tiny little red crystals that I made, I don't think they can be anything else other than calcium osmate because they're insoluble in water. Under the microscope, they did have a kind of distorted octahedral structure. And they're red, just like other osmates. So there you go. Essentially what happened was that most of the calcium chloride was converted to calcium hydroxide, whereas a very small percentage of it ended up becoming calcium osmate. Very, very low quantity calcium osmate. And that brings the total number of osmium compounds I've made up to 15-ish. Earlier in the video, you may remember seeing that really thick precipitate of osmium oxydiamine hydroxide that I got, that brown powder that may or may not explode if you heat it in air. Well, before the precipitate got really thick, I centrifuged the solution. I got a small amount of it out, and then it dried, and then it quietly converted to hydrated osmium dioxide, unlike that other stupid piece of shit. And I got a sort of flat, sizable chunk of it, and it looks pretty metallic. I took some images of it under the microscope, and the images are surprisingly terrible. Alright, last order of business before I end the video. Poor man's chemist. You want me to make osmium oxalate complexes. Not with my current setup. I'm thinking about maybe investing in a crucible of some kind. I know he used a test tube when he made his, but I'm not sure how well that would hold up. If I could isolate potassium osmate, like actually crystallize it and then just dissolve it in neutral water, that would go a long way. I'll think about it. I'll mull it over. I'll try and come up with some kind of setup. I'm going to need like a propane torch or something like that, for sure. I'll have to get some potassium hydroxide. I'll have to get some potassium nitrate. Yeah. I think if I want to go further with the channel, that's the route I'm going to have to go, because this sodium osmate stuff is like, it's limiting. And I think I'm getting kind of sort of close to the limit of what I can do with it, or at least what I think I can do with it. On the other hand, I did send poor man's chemist 4.3 grams of osmium. That's around $170 worth of the stuff, and he hasn't touched it yet. When are you going to get around to osmium chemistry? Come on. Like, that's why I sent it to you in the first place.